All right, thank you, Bill. Thank you, Singyon, and thank you, Sudha, for an excellent talk. We will open the session for Q&A. I already see folks have started asking questions, so let me share my screen, pull up the slide of questions. All right. So the first question is, are slides present somewhere for reference? Yes, of course. We will. This session is being recorded, as well as we will have slides. We will post it on the Apache Pinot Slack channel on the location where we're going to post it. So feel free to join the community on Slack to get more details on where you can find it. Okay. Second question, what are the tools you use to find the bottlenecks? Looking at the timestamp of the question, I think it is for Singyun's talk, which was for scaling Pinot. So there's a few things. First, we've made execution statistics first-class citizen in Pinot, so we know exactly, we emit metrics as well as information that helps us capture which part of the code is taking how long. So that helps quite a lot for the getting a high-level picture of the problem. Also, I think we used your kit for the lower-level presentations for debugging. I think that's just a high-level overview. Singyun, if you want to answer that or add more details to that.
Yeah, so I think Maya pretty much covers the important details. So we used your kit for profiling the low-level JVM, like in terms of, so if you use the your kit, then you will be able to see some like memory profilation and also CPU cycle profilations. So you can it actually shows the hotspots. If some operations are taking a lot of CPU cycles, then you can identify that. And also, the second question, wait, can you scroll up? Yeah, so I think the second question is, how do I approach such a problem? So I usually, whenever I see the performance issue or need to find the bottlenecks, so I use some framework. So I first, I usually use the top down approach. So I first need to try to find out whether the broker is the bottleneck or server is the bottleneck. And if the server is the bottleneck, then is the real-time server or offline server is the problem? And then I go to look at all these performance metrics and to see if I can find some issues appearing on the metrics. And otherwise, if we cannot find any information from the metrics, then we usually go with the running your kit to profile the low-level operations on what it's happening. Yeah.
Thank you, Singan. The next question, I think that's upvoted, is what's the unique problem that's being solved by Pinot as compared to other distributed DBs out there? Thanks for the excellent question, Milind. So if you think about OLAP, right, there are multiple ways to solve it. And if you look around in the ways that people have tried to solve it, there is multiple different patterns. On the one hand, you will have solutions which are just using traditional OLAP solutions and data warehousing, wherein you're just have OLAP table, effect tables, and powering dashboards off of that. And when performance or latency becomes critical, folks try to pre-cube it and put it on solutions like a key value store, Kylene, or other solutions to solve their latency problem. But what's very unique about Pinot is between these two ends of spectrum and anything else, Pinot actually covers the entire spectrum. You can actually power highly dimensional data, power dashboards which has really highly dimensional data and complex query on the one hand, to the other extreme where you can have real-time analytics at member scale. We're talking about 50,000 QPS cumulative just for a feed impression kind of use cases, or impression discounting use cases for Pinot, where where latency and throughput are extremely mission critical. So Pinot is unique in the sense that it actually solves the entire spectrum of the analytics problem. It is providing you a way to do OLAP at OLTP scale. And the other thing is that I just talked about the two ends of the spectrum, but there is, areas in between where you want to compromise storage versus latency. And Pinot provides you hooks and specialized indexing such as star tree to say, okay, I'm willing to pay so much cost in storage to get so much latency, right? And you can fine tune the knob to move anywhere in the spectrum that you would like. So hopefully that answers the question to some extent for you, Milind. And if you have follow-up questions, feel free to reach out on Slack and we'll be happy to answer it. This one, for the performance profiling.
We already answered this question. We use your kit for. Yeah,
okay, I think the next question is for you, Singen, again. Performance improvement in the second presentation, are they publicly available?
Yeah, so this is publicly available, and actually Suda used a lot of these performance optimization features that I presented to her use case to improve her own use case. So all these like performance optimization features introduced in my talk can be applied to like most of the use cases outside. Yeah. So all the optimizations are available to use in today. Yeah.
The popular question from JF is test. The answer is test passed, I guess. Can Pinot connect to Kerberized Kafka? I think this is a general question, not specific to a speaker. So I guess I can take this one and I can ask any other speakers if they want to add details. So yes, we do support ACLs for consuming from Kafka. It's just basically a pass-through config for the credentials that you specify, and it's just passed to the Kafka client. Singen, do you want to add anything else on top of that?
Not really.
All right. Yeah, okay, no problem. I think this, going by the timestamp, this question from Andrew first is most likely for Bill. What was the schema and data flow for how, and how was the time series functionality used?
Yeah, so I guess I can verbally say, so the schema itself is sort of very similar to the slides, which will be made available on the Slack channel soon. It's basically we're keying on we're keying on whatever your set identifier is, right? So GOUS in our example, and then the value is just a binary. So in Theta Sketch, you produce these binary sort of representation of the sketches that represents a hash set, if you will, right? But with it's much more compact. And that's sort of the schema. And how was the time series functionality used? We didn't really use time series for our particular uses, just because we didn't have any, our product didn't really need to use the time series functionality. But happy to chat offline if yeah, I hope that answered your question.
I think the next question from Priyank is also for you, Bill.
Yeah. So did you measure the change in error latency where you have higher cardinality of sets? I guess I'd love to get a clarification. Is this like error divide by latency, or is this like error and or latency? What we did measure is a change in error as a function of, or a change in error and latency as a function of the size of the sketch that we can tune at runtime. But we didn't really, so we used our particular data set that we know will be, serving real traffic. So we didn't mess around with the shape of the data. We want to make sure that we fix the shape of the data to as close to, production as possible, and measure error and latency based on that. Yeah, so I hope that answered your question.
And I believe you did have high cardinality data sets, columns, right?
And yes, we did. Yeah, a lot of our sets have high sort of LinkedIn scale data, right?
Okay. So next question is from Harsha. Is there a comparison benchmark between Pinot and Druid? So yes, we had done a benchmark, I think a couple of years ago, and the results went into our Sigmart paper. Essentially, what we found is that if we, for the, out of the box setting for Pinot and Druid with, Pinot does not actually do caching. I think the latency in Pinot were far better than on Druid. But this is somewhat of a dated result. We're happy to conduct these experiments again. Feel free to reach out if you wanted to get more details on what was done in the past. Priyank, what kind of problems one should be aware of when consuming from a Kafka cluster with just one topic versus Kafka cluster with multiple topics? So again, I think this is a generic question, not specific to any of the presenters. So I'm going to take a first shot, and then if anybody wants to add more details. So basically, Pinot, as of today, just consumes from a single Kafka topic. We don't do like, at the moment, we cannot or do not consume from multiple topics for a single table. Within the topic, you can have multiple partitions, of course. So I can limit the, or I can specifically say what you want to be aware of in that scenario. Essentially, what you want to make sure is that you don't have either way too less or way too many partitions, because each partition actually becomes a, there is a client per partition times the number of replicas for the consumption to happen. And if you have way too many partitions, let's say 256 or so, and your data is not that much, you will end up with a lot of tiny Pinot data segments, which is not really good for performance. I think I can have Sudha also add to this, because she ran into similar issues. If you have any comments, Sudha.
Yeah, Mayank. So for us, we did try with, so I think one point that you aptly mentioned, right? So one table can consume only from one topic, but otherwise we did have multiple topics and map different tables to it, and we were able to do it without any issue. I think the only thing that we will have to worry about is, the traffic, that the expected traffic, and how many brokers, because there is some issue with the scalability of brokers if we use the normal, the Kafka cluster version that we were using, the Confluent one. So that would be the only thing. But otherwise, yeah, I think you've covered it.
Yeah, I think so. The question was indeed for you. You provided more information than I did, more relevant information than I did. Okay, the next question is for Theta Sketches. So Bill, all yours.
Yeah, so how is Theta Sketch different from Hyperlog logs from a functionality wise, and which one performs better for union only functions? There's, outside of the algorithm itself is different. If you only need union, Hyperlog logs are, and again, this is on the Theta Sketch sort of Apache sort of website. Theta Sketch is about 2 to 16 times bigger in terms of the size if you want the same accuracy for unions. So because the sketch size is bigger, I would presume that the wouldn't benchmark against Hyperlog logs, because like it just doesn't work for our use case. But I would presume because of this large change in like the size, there's some sort of latency differences as well. But if you just only fix error margins, it seems like Theta Sketch is 2 to 16 times about. That's according to the documentation. Yeah.
Yeah, thanks, Bill. And I also think they claim that, or they state rightfully so, that is HLL is a lot more accurate than Theta Sketches. The next question, I think I'll let Singyun take that one.
Okay, so so basically the forward index is the index. So we are given a document ID, and we need to look up the actual column value. And then by default, we actually, instead of storing all the raw values of the column, we actually use the dictionary encoding to have better compression for the column data. But that particular use case that we saw on the feed was that the dictionary was actually the bottleneck. So what we did was to implement the raw forward index, which basically stores the raw data. And then we store it in a way that we keep the header, which stores the offset information, and we also have the payload where we stores the actual column values. And I also posted the documentation on the raw forward index on the chatting. So if you're interested, then you can go there and read the details.
Okay, I think the next question is on framework for performance. I think we already answered that. If there are any follow-up questions, definitely reach out to us on Slack. Just in the essence of time, we will take one more question because we have 2 minutes left. But before we close, I want to make sure that we acknowledge that we will post the slides as well as the recording, as well as answers to all the questions which were not answered here, as well as the ones that were answered here, for you to be accessible. So let's just take one last question. This is again for you, Singyan.
So the question is, how do you assign replica groups, and what if the server is lost? So there is an API on the controller side that we can assign the replica groups by putting some configurations on the table config. And then if the server is lost, this is actually a very good question. Then the broker is actually smart enough to look for other servers who's serving that missing segments. So actually, we usually for LinkedIn production environment, we usually keep at least 3 replica groups by default. So even if you are missing a server, we can go to another server that from a different replica group who serves the segments, and then we can answer the query. So in this particular case, we will not be able to span to a single replica group, but we will span to 1 or 2 extra more servers. But we still don't fail even if the server is lost. Yeah.
Thank you.
And then to fix it, you can also run the rebalance after replacing that problematic server. Yeah.
Thank you, Singyan. So I think we are all out of time now. Thank you, everyone, for taking time from your busy schedules to join us. We really hope that you all enjoyed the talk, and we look forward to seeing you next time in the next talk. In the meanwhile, look out to tune in into our Slack channel to learn more about Pinot, or if you're already a user, we are there to help. Definitely reach out to us on that. Thank you, everyone, and good night.